going? How's everyone doing?
Good.
Great, not good at all?
Coronavirus?
Just everybody? All right, so my name is John Ezekiel. People call me Zeke. And I have over 8 years of professional experience developing. I've done everything from project management to full stack development, so I have a little bit of idea of what I'm doing. But it's important for this presentation that you know that I'm just some guy and I don't actually, have any sort of accolades. I'm doing independent research here. So if at any point you find something wrong with my presentation, just raise your hand. It's not like a full presentation. We'll work through it, okay? So that's just a little caveat to what we're going through. So what I wanted to do for this presentation is, for me personally, when I'm in development, there's so many concepts that you have to worry about as a developer, and there's so many things you're just trying to, keep your head above water, that it's hard to really connect the dots as to what's actually happening. And I find it is really important, at least for me, to understand what's actually going on at the base, at least at the fundamental level. A great example of that is, for some reason or another, without any experience, I was tasked to do system administration work, which was, completely ludicrous. But they tell you to figure it out, and so I figured it out. And with Linux system admin, if you just know where scripts are stored, where everything is organized, because that's really all it is, it's a lot easier to flow through it. So I hope there's some kind of epiphanies that some of you might get with this, but if not, whatever. So anyway, we're doing the journey, so everyone should be familiar with this. We're just doing request, which is whenever you actually press the button, that's going to actually run some server code to, probably a server in San Francisco or Washington, depending on if you're using Amazon or DigitalOcean. And then there's a response after it's done its logic. So we're going to start with the request. What I have here is just a simple form. Changes to that. Everyone's seen this before, hopefully. If not, it's okay. This is just HTML. I'm trying to be very verbose, so everybody who doesn't know this is HTML, and it's just a regular form. And so we're trying to figure out what happens when you press that submit button. How does it actually get to zeros and ones? Because that's literally what's happening, right? All these computers eventually compile down to zeros and ones, and I think that's crazy. So I want to figure out how is it getting there. So we're going to go as detailed as possible. This is going to resolve to a post request, and we'll get to that. We'll get to each of these in a second. It's going to run through cable lines to the server that's actually taking the request. And it looks like I have some sort of issue with the sizing of my screen, but you need to get the DNS, right? So you need to actually figure out where the server request is going. So any questions so far? The premise is clear? Okay, cool. So when we do a post request, what is that? It's just an HTTP method for sending data to a server. And this is another thing where I'm clicking, it's something that clicked for me when you're talking about all these protocols, SMTP, HTTP, all these acronyms that, there's a million of them and people make a million more. It's important to know that it's just a protocol, and I like to just say it's a bunch of people shook hands on how we're going to send data. And that's really all it is. It's just a protocol. And I think it's important to remember you can break these protocols. There's nothing enforcing you besides whatever's on the end of that code. So right here I have the form that we just talked about. And so I don't know exactly what tools the browser used to actually send requests. I'm imagining something with curl. So I just went ahead and transpiled what this is going to be to an average curl request, which is just a command line. So it's going to be the location, which this is going to change, but this is going to be the same domain. I started with localhost and it changed to zeek.sh, but it remains the same. We're just going to have a domain, and then the form data that we had in the previous thing just goes into these parameters. But that's not actually an HTTP request either. And to shed some light on what the protocol actually is, this is that curl request transpiled down to an HTTP request. So here we see kind of what dictates how the protocol is done. Every HTTP request demands that there's a header with information about what you're actually sending. A lot of you probably seen multi-part form data. Maybe you've had some issues, the URL encoded ones or different types of content types that you're going to be doing. And then there's a boundaries that's been defined here, and that's what actually dictates where the data is and what it's assigned to, right? So this is by far the worst slide I have. I am a software developer, and this is a hardware problem, so clearly I'm useless. So I'm gonna need your help here. All right, this is just an RJ45 pinout. Everyone knows this. Has anyone ever actually ran their own Ethernet, crimped the cables? Anybody? Yeah, cool guys. Really?
Yeah.
Wow, I've never had to do that. I bought the spools of Ethernet, but my job always had one. Anyway, so yes, very weak, and I just want to get the gist of what's happening because I said we're following all the way down, so I'm gonna do this the best I can. You know, when we're talking about communicating over the line, we are talking essentially about zeros and ones at that point because zeros and ones essentially translate to on or off. So the way that the wires actually send that data is that each on and off has a specific, and help me out, I know Alex, you might be being like, that's completely wrong. But there's a minimum voltage that it determines is going to indicate 0, and a higher voltage that indicates 1. And so there are standards and protocols in place for interpreting that data and getting back what was actually sent over. Is that as correct as I can be? Did I enrage anyone with that slide? No? We're good? Okay.
There's also the clock of the signal, there's the length of the wire, there's reflections.
Yeah, there's so many things. And with this, I'm hoping to just shotgun as many concepts as possible, and hopefully something will interest you and you can kind of dig into it further, right? So then this gets into your router, or if you're on Wi-Fi, you know, wirelessly through eventually your router. And it is really cool. This is actually a submarine cable map. I don't know, this is another part where I spent like 6 years never even thinking to myself, how does data get to the other side of the world? Is it just like Wi-Fi across the Atlantic Ocean? No, it's literally, you can go to submarinecablemap.com, and this is all the lines that we've run to make sure that the world is connected at all times.
Can I do a shout out?
Yeah.
See the yellow one coming from San Francisco?
Wait, hold on. That doesn't work at all.
Yeah.
Okay. Does it still work? Okay, cool.
Looks like someone's running
How dare you, Chris? Anyway, what? Yeah, I am. Which one?
The yellow one coming from San Francisco.
Okay.
My company helped run that one.
Really?
Yeah.
Isn't that
across the whole Pacific Ocean for that one.
I don't see a yellow one.
It just sits on the bottom of the ocean?
Just sits on the bottom of the ocean.
Why
The
don't
shark
you
seen
yellow?
it?
Sometimes.
Yeah. I heard that was a problem.
Very deep water sea sharks.
So I thought that Level 3, the company that was responsible for running these cables, is that not the case?
That was a long time ago. That was in like the 80s.
Okay.
There's a bunch of companies that run it.
Oh, it's all contracted out. Cool. Well, anyway, I thought this was super neat, just to kind of really drive the point home that there is no easy way to do this. We had to run wires everywhere.
Why don't we just go over the land?
So anyway, so we had the post request. We're sending it to our system, but where is actually the server? We don't know yet because we don't have the domain name server part yet, which is a hierarchical lookup tool, which I think the best way to describe it is a yellow book, right? I mean, it's just an address book of when a domain is entered, what does that resolve to as far as an IP address. So we've identified where, the code, the data we want to submit is submitting, and we figured out where it needs to send to. Everybody good so far? Cool. So now we talk about the server code. That was the request we had. I'm just trying to make sure it's very obvious what we're doing. Now, there's a few things we have to do before we actually get to the actual execution of the script. First of all, there needs to be, I have responsibilities in order. You need a web server that's going to listen to and receive requests on the ports that we've specified in the HTTP protocol. And we need a raw request based on whatever configurations that web server has. Find the script, which is part of the config, of course, and then execute that code. Has anybody rolled their own web server before? Nginx, Apache? Cool. Yeah, it's not too hard. It's actually pretty simple. Like I said, it sits on port 80 or 443 if you're doing an SSL connection. And then it's constantly listening for requests on that. And here's a general overview of what is all going on in that part, we have Nginx is what my preferred web server tool is, which goes to what's called a common gateway interface. Again, another series of specifications to execute applications as if they're like console level applications, and specifications for making that work. It's common gateway interface, so I feel like you can infer what that
Doesn't use that anymore, or never did. It uses fast CGI.
Fast CGI? What's the difference between fast CGI and CGI?
Fast CGI works over TCP. CGI spawns the operating system process and sets up an environment.
Okay. So if I wanted to fix this presentation, I
Put
would
an
do
F in
fast
there.
CGI. Okay, cool. Which, I was going to get to in a sense because, the Nginx, this is the configuration I was saying. So with this, I'm using FPM, which is a fast CGI process manager. So we're at least tangentially close to what we're talking about. All right, we're good, it's fine. So yeah, in Nginx, if you've never seen it, this is just a object that's going to define what Nginx should listen for. So I have it set to listen to port 80. The root is where it should find those scripts. What the index is called, server name is, that's really important because that's what it's going to respond to. And then all this stuff down here is just, if you don't go to like a fast CGI or a process manager at all, it's almost like a single file line. So when I want to handle requests, I want to spawn child processes for handling those individual requests, which is where something like fast FPM for PHP, fast process manager, comes into play. And the actual script that we're going to be running, it was very inspired by Davin's post. I think you're going to really love this, Davin. We're going to go ahead and just return this code. It's going to be a 200. Well, does anyone want to guess what's wrong with this? Why we wouldn't want to turn it like this? No?
Status code's wrong.
Status code's wrong? Arguably, right? No?
Or either that or the success is wrong.
So anybody who's confused about why this is funny to one person, the reason is, again, we're talking about HTTP, we're talking about protocols, and the protocol that dictates that whenever you're sending a status code which is successful, that resolves to 200. If you've probably seen 404, that's an HTTP code saying that when it went to the root of my configuration to find the script I was looking for, it couldn't find it, right? 500 is internal server error. So what I'm doing here is basically saying that the request was successful, but I'm burying in some additional metadata saying that it's not, just to really trip people up. So anyway, okay. What we've talked about so far is stuff I'm very familiar with, except CGI, and that I feel like I can speak intelligently for. So another caveat, we're going into the script now. And this is going to be a different story. Maybe Chris can help me out with this. I don't know. But first, we're going to talk about the gateway interface because I forgot about this slide. And that is just, like I said, communicate with programs that run like console applications. Anyway, back to what I was saying. The script. How does the actual script run? So we have the script here, and like I said, eventually this is going to get compiled down to zeros and ones, except it is not. What's actually happening is PHP is an interpreted language, which means that it needs an interpreter. And the interpreter itself is what is compiled down to machine code, not the actual PHP code itself. So you might be asking yourself, well, what is actually the interpreter in this instance, and how does that get down to machine code? And what we're talking about now in the context of PHP is called the Zend engine. That is the precompiled binary that interprets PHP code. So we're going to look at that real quick. The responsibilities of the engine is to tokenize the script. Tokenization is really just, I have an example for this. PHP has a really cool method called token get all. And what tokenization does is just really identify every piece of your code that's going to need to be executed in some way. And that's what this looks like. These are all, you'll see there's constants defined for what it's actually assigned to. So white space has its own constant, variables have their own constant. And that's what I mean by tokenizing. Does that make sense to everyone? Cool. So we're getting closer. It's starting to look a little less readable. The next part is parsing. It's going to construct what's called an abstract syntax tree. And I'm going to fumble over the definition of that while this is open. So an abstract syntax tree is essentially the compiler building a, would it be right to call this like essentially a BST? I guess not. It's just abstract, right?
Use the word, what's the right word?
Huh?
Alex.
It's a tree.
System has it. Just an AST.
Okay, gotcha. So yeah, it's just going to be a tree representation of how it's going to execute your code in a sense. Everyone good with that? Any questions so far? All right, so yeah, with these two, the tokenization and the actual abstract syntax tree, then it does the actual compiling, which consumes that syntax tree and emits what are called opcodes. And these are example of PHP opcodes. So the Zen engine, as it's interpreting your code, it's emitting what I feel like it's very similar to assembly-like language to dictate how your code is actually going to be run. So if you've ever seen assembly, I feel like that's very similar to what this is doing. So opcodes are essentially, like it's just ways that it's communicating those instructions once it's interpreted by the engine. Any questions so far? So that's pretty much the whole journey in terms of getting to the zeros and ones, and it's a little confusing because I initially thought that this was going to eventually compile down to zeros and ones. So I thought it was interesting that it's not. It's just going to be interpreted by something that has been precompiled. So the very last thing that I think we can talk about is how is the compiler itself getting compiled down to zeros and ones. And so again, this is way out of my wheelhouse, but I just wanted to give you some ideas of what's happening. That PHP interpreter is actually written in C, which is a lower level language. And then C, of course, does get transpiled down to assembly, which then eventually gets transpiled down to, I think transpiled is the wrong word, compiled down to zeros and ones. I don't have an example of how, any kind of Zen engine assembly. So I just have what I feel like is my favorite example of assembly. This is some of the code that ran on the Apollo moon landing. There's just, I thought they had some really good sense of humor in their directions. So yeah, see these. If you ever, has anyone ever dealt with assembly before? Yeah, so these are lower level instructions. Typically, a lot of them are going to be, defining what registers in memory you're going to actually be assigning values to, and what operations, and the assembly is going to take, those multiple registers and do whatever operation you actually want to do to those. So that's as layman's terms as I feel like I can get in for assembly. And that's pretty much how the entire thing goes. Once we have the server code and it's compiled down, it gets interpreted by the Zen engine, which then sends the response back, which I just have an object right here. That's JSON object notation. It's just JSON object. So, and then these are my sources. So that was, I think, a lot shorter than I thought it was going to be. But any questions?
Well, I'd add one thing about the
Sure.
zeros and ones, your quest for zeros and ones.
Yeah.
Is that even though the PHP the script doesn't get compiled down to true binary, it does get compiled down to P code, depending on what term you want to use for P code these days.
Mm-hmm.
But it's the same sort of a thing, where it's some sort of an intermediate form. That is a binary form that is translatable directly to zeros and ones. It's just that the thing that is translating is not assembly language. It's something that another assembly language component reads and interprets.
Mm-hmm.
But it's
So
still zeros and ones.
So the PHP gets compiled down to something called P code or something similar to that, and the interpreter interprets that, and that binary-like format is what eventually emits the opcodes that the Zen engine is going to send to the I'm assuming processor.
Yeah, the opcodes that you get out of Zen essentially is the P code.
Okay,
Yeah,
gotcha.
it's a, yeah.
And that's why what PHP 7 got so much faster, they were able to cache that stuff a lot better.
Yeah, I heard that the PHP 7's performance improvements was like something to do with arrays, right? How it like cached arrays.
I don't know, I just know that internally they improved the caching of like that intermediate layer, and that's part of the reason why it got so much faster.
But every scripting language goes through the same sort of a thing, where you take some sort of a script and you reduce it down to the abstract syntax tree, and then you output some sort of code. And many modern compilers actually run that through LLVM or some process like that, which is almost the exact same thing. But when you run it through something like LLVM, it's smart enough you can tell it, I want you to go to these various targets, multi-platform and all kinds of weird, crazy things that you don't have to deal with. But it's still, it's binary data. It's just not binary machine instruction.
Yeah.
Yeah. And there's no bottom either, because
That's right.
you know, you've got a lot of interpreted languages that have just-in-time compiling, to where it'll take the opcodes and it knows the CPU instructions that correspond to the opcodes and will dynamically compile, store it in memory, and run it as a binary. So it runs on the hardware itself.
Java does that.
JavaScript does that as well.
JavaScript is,
Lua.
One version of
The
Python.
most
does that.
difficulty
version
I've
of
had
PHP does that?
building this presentation was really like, where do I stop? You know what I mean? Because like each one of the things I went over is just a rabbit hole of
The assembler is not even the lowest level, because there's microcode on the CPUs, so the assembler can sometimes get transpiled by the CPU and changed in the CPU. There is no bottom.
Here's a fun one. So you'll produce, let's say C++, you'll produce some assembly, right? So assembly, it looks exactly like the English version of the opcode that you mentioned, but the assembler itself, there are
That's just an interface.
meta instructions in assembler for x86, for ARM, for etc. And those meta instructions turn into more assembly, and turn into more actual machine code, the literal, bits and binary that's into the CPU. So you have, even in the high-level programming at the assembly level.
So
There is no bottom.
it's kind of really hard to like say like, behold, the citizen one set all that script. And that was the goal of this, but yeah, I got as far as the Zen engine and I was like, okay, I mean, this is good.
But he makes a valid point that really, once you get down to assembly language and outputting machine instructions, that's the furthest that most people ever go to. There's a few people who get into the microcode, which is a totally different thing.
One more level down, huh? So, any other questions? Or?